All right, today we're going deep, really deep, into the raw data of the Bitcoin network. We're on a bit of a micro-investigation, a treasure hunt really, to uncover this hidden gem of efficiency. It's a tiny but absolutely brilliant piece of code that helps keep Bitcoin transactions as small as humanly or, well, digitally possible. So let's get into it.
So here's our roadmap for this little journey. First, we're going to peek inside a regular transaction. Then we'll zero in on how the inputs get counted. After that, this is the good part, we'll uncover the efficiency secret itself, break down exactly how it works, and then finish up with a really critical warning for any of you aspiring devs out there.
Okay, let's dive into this. Section 1, inside a Bitcoin transaction. Yeah, we're popping the hood to look at the raw bytes that actually make all of this stuff work.
I mean, have you ever really stopped to think about it? When you send some Bitcoin, what are you actually making? It's not just some number that changes in a database somewhere. No, it's a super carefully structured package of data, a literal map of bytes with a very, very specific layout.
And on that map, you've got several different fields. But for today, we're going to zoom way in on just one specific area, the field that lists the inputs for the transaction. This is where things get really interesting. So that leads us perfectly into Section 2, counting the transaction inputs. Think of this as the very first clue we need to solve our little data puzzle.
Okay, so picture this. When the Bitcoin network gets a transaction, the first question it has to ask about the inputs is, hey, how many are we even dealing with here? So the inputs field always starts with a simple number that just declares the total count of inputs that are about to follow.
So you gotta have at least one input. That's a rule. But what about a maximum? Well, there's no hard limit written in the code. But because the whole transaction itself has a size limit, you practically top out at a few thousand inputs at most.
And this is where we get to the heart of it all. Section 3, the compact size efficiency secret. The way Bitcoin stores that simple little input counter, well, that's where we find this brilliant example of its smart packing system.
This whole magic trick is called CompactSize. The official name is a variable length integer format, and its one and only job is to encode numbers using the absolute minimum amount of space possible. And that's absolutely crucial when every single byte counts on the blockchain.
You know, I love this analogy because it just makes perfect sense. You wouldn't use a massive suitcase for just one pair of socks, right? It's just inefficient. You'd grab a small bag. Well, CompactSize applies that exact same common sense logic to data. Small number, small bag. Big number, big bag. Simple.
So let's get into the nitty-gritty. Section 4. How does this thing actually work? It's time to crack the code on this super clever system. So the big question is, how does it know? How does Bitcoin decide whether to use a tiny little data bag for a small number or a bigger one for a large number? Well, it all comes down to a really simple set of rules. Okay, this table lays it all out. And check this out. This is the coolest part. Look at that top row. For any number of inputs from 0 all the way up to 252, and let's be real, that covers most transactions, it uses just one single byte. That's it. It's unbelievably efficient. It only starts using more space when the number gets bigger, and it does that by adding a special prefix. So here's the key. Think of those special prefixes, 0FD, 0XFE, and 0XFF, like little instruction tags for the computer. When a program reads the byte 0FD, it immediately knows, okay, this byte isn't the number itself. This is a tag telling me that the real number is coming up in the next 2 bytes. It's such a simple, elegant way to stay flexible without ever wasting space. All right, before we wrap up, it's time for our last section, and this one is super important. Section 5, a critical word of warning. Because in the world of code, names can be tricky, and this is a big one you don't want to get wrong. So, you have to know this. We've been talking all about CompactSize, but if you go digging in the Bitcoin source code, you might see other similar terms like variant or compact. And listen, this is a classic trap. They are not the same thing, not even close. They're totally different systems for different parts of Bitcoin, like the UTXO database or block headers. When you're talking transactions, it's CompactSize. Got it? All right, let's wrap this all up. What did we learn? 1. Every single Bitcoin transaction kicks off by saying how many inputs it has. 2. It uses the super clever CompactSize format to store that number efficiently. 3. CompactSize is smart. It uses a variable number of bytes so it never wastes space on small numbers. And 4. This isn't just some random detail. It points to a core design principle of Bitcoin, an absolute obsession with efficiency right down to the last byte.
And I'll leave you with this final thought. This intense focus on efficiency, it isn't a one-off thing. It is woven into the very fabric of Bitcoin's code. It really makes you wonder, right? What other brilliant little designs just like this are hiding in plain sight, just waiting to be discovered?